Migrating Java applications to the cloud. In this session, we will discuss the factors we need to consider while migrating Java applications to the cloud. After completing this unit, you should understand the different levels of application migrations along with understanding what types of applications should be migrated. We will also discuss how to make Java applications cloud-ready and what cloud services should you choose while running your applications on the cloud. There are three different levels of migrating applications to the cloud, which range from least amount of code change to substantial amount of code change. First is application re-platforming. If you want the user experience to remain the same and you are comfortable with the quality of your existing code base and your dependencies can be satisfied with the runtime and services on Bluemix, then you can deploy your applications to the IBM Cloud as is by simply adding a manifest.yml file to automate application deployment. Manifest.yml file is a Cloud Foundry concept. Some repackaging may still be required. Next level is application modernization. Do you have dependencies that are now out of support and therefore it makes business sense to refactor the applications? Also, if you want to move to the cloud platform to take advantage of dynamic scaling and ease of maintenance for cloud runtimes and services while maintaining connections to on-premise systems of record, then you need to make code changes and retest the new subsystems as well as do an end-to-end testing to ensure new code has not introduced new bugs. The third level is application revisioning. If you need a new user experience, you are going for multi-platform development and want to repackage your applications as microservices, then this is the best time to do so. Effectively, it will be a brand new development activity while harvesting some old code. Let's get ready to migrate applications to the cloud. What are the common characteristics of enterprise applications? They are usually not built with cloud compatibility in mind and may be running with older versions of libraries, software dependencies, etc. They may be built on WebSphere stack products, for example, portals with WebSphere Portal Server or departmental enterprise service buses built with Data Power and IBM Integration Bus. They can have deep ties into internal IT, especially in cases where you not only read from but update on-premise systems of record. They may read from and update multiple systems that are not specified as APIs and have deep ties into corporate security systems, for example, LDAP, ISAM, SiteMinder, and have ties to corporate standards. Often, enterprise applications have high and well-specified quality of service attributes, where SLAs on the availability and performance of the application are promised to customers. There are differences in assumptions made by enterprise applications as compared to cloud-centric applications. Enterprise applications assume that infrastructure is stable, that software components constituting the application are co-located, and production version of the application is being maintained by an operations team. Consequently, disaster recovery is another team's responsibility. On the other hand, cloud-centric applications are built with the assumption that infrastructure is constantly changing, that application components can be globally distributed, and DevOps, including disaster recovery, is the responsibility of the cloud developer. While you plan for migration, knowing the business drivers for your applications is critical. If your business is driving the need to rewrite and repackage your code, then it is a good time to transition to the cloud. The dynamic scaling on the cloud and the ease of maintenance of cloud services should enhance your business solutions. Also, knowing your applications and users is key. Are your applications working efficiently in their current form? If not, then rewriting them makes business sense while you're migrating them to the cloud. Now, are your applications cloud ready? An application is cloud ready if it can be deployed into either a public or private cloud. This means application needs to be designed in a way that it can take advantage of capabilities provided by platform as a service layer. Also, applications should not break because of design limitations that collide with assumptions made in the PaaS layer. In the next section, we will discuss the simple rules in application design to make your existing applications cloud ready. You need to build a migration plan. Therefore, you should develop a template architecture for your applications. Use this opportunity to pay technical debts and promote decoupling principles as you migrate applications to the cloud. Let's dive into design principles for cloud-ready applications. You can never move an application to the cloud if they are not cloud-ready. So, we will look into how these applications can be declared cloud-ready. At this point, let's also talk about cloud-centric applications and why they are important. Cloud-centric applications are specifically written to run on the cloud, usually within a PaaS. These applications are built using different tools and runtimes than traditional applications. For example, a cloud-centric application may use a NoSQL database like Cloudant or MongoDB instead of relational database. Also, cloud-centric applications have different infrastructure dependencies. We are going to cover design principles for cloud-centric applications later in this session. The application dependencies, including runtime environment, determines whether infrastructure as a service or platform as a service environment is more suitable for an application. In the next session, let's first dive into what makes an application cloud ready. Design principles for cloud-ready apps are: don't code your application directly to a specific topology. The host names, IP addresses, and the number of application nodes in use can change at a moment's notice on the cloud. To take advantage of dynamic scaling on the cloud, build your application to be as generic and stateless as possible. If you must use a singleton, then make sure that you have a voting protocol enabled to enable the remaining nodes to recreate a singleton if the singleton dies, and keep a permanent backup of the singleton state in a shared repository like a database. Next, do not assume the local file system is permanent. Since a node can be moved or taken away, you cannot make any assumptions about the longevity of files written to the file system. Therefore, keep the information in a remote store, for example, a SQL or NoSQL database. Don't keep session state in your application. If you cannot eliminate session state entirely, the best practice is to push it out to a highly available store that is external to your application. You can put it in a session cache service or Redis or Memcached or in an external database. Also, don't log to the file system. If you write your logs to the local file system, then what happens in a crash that takes out the entire container or VM where your application was running? Or if your PaaS layer decides to scale down your application and remove the VM or container entirely. In both cases, you have lost valuable information for debugging problems. Therefore, use log aggregators that can be redirected remotely. Don't assume any specific infrastructure dependency. Applications should consult an external service registry to resolve service endpoints or delegate the routing function to a service bus or a load balancer with the virtual name. Do not assume any specific infrastructure dependency cannot be overemphasized. Let's move on to another design principle which says don't use infrastructure APIs from within your application. Shift the responsibility for infrastructure services to the provider. Once you start making assumptions about the infrastructure that your application runs on, it makes changing that infrastructure even more challenging. Your application should be concerned with solving the business problem it's aimed at, and not with manipulating the infrastructure it runs on. Therefore, leave PaaS solutions in the PaaS layer and keep them out of your application code. Don't use obscure protocols. If your application is using any older or non-standard protocols, now is the time to take this silver lining opportunity to modernize and standardize. For example, EJBs using IIOP were cool at the turn of the millennium, but the world has moved on. Therefore, moving to an HTTP-based infrastructure based on standards like REST or even SOAP and WS standards will make it easier to port your system to a new environment and will also enable additional business opportunities provided by API management. You may want to consider asynchronous protocols such as IBM MQ, AMMQP, and MQTT. Rather than trying to make HTTP into something it isn't, like a reliable messaging system, please make sure to take a minimalist approach and apply the right tool for the job. Please don't rely on OS-specific features. Instead, rely on services provided by your middleware infrastructure or your service providers. Don't manually install your application. Cloud environments are quite likely to be created and destroyed more frequently than traditional environments. Therefore, your application will need to be installed frequently and on demand. The installation process must be scripted and completely reliable, with configuration data externalized from the scripts. You should also minimize the dependencies required by application installation. For example, what is your minimum configuration? Does the database really need to be available to install the application? Or would it be a better option for the application to start without its database, simply report the problem, and then increase function when the database becomes available? These are some of the thoughts that are worth considering. In cloud migration, application has to change at some level. Therefore, to ensure a successful migration, it is necessary to have application tests, preferably automated, and application performance baselines, as well as processes for gaining access to the test data. As you migrate to the cloud for better performance, better user experience, and ease of maintenance, you can consider refactoring your applications while preserving the behavior. Your application has 3 layers: the UI layer, business logic layer, and the data services layer. You can substitute the layers with 9 rules compliant replacements as we just discussed. Also, your application is broken into functions that span these 3 layers. You can refactor larger functions into smaller ones, thus developing microservices. And your application is calling several services, therefore you can benefit from developing a shared services architecture. As you consider migrating applications to the cloud, it is a good time to pay technical debts by developing automated functional and performance test suites, by fully automating code and configuration deployment schemes, by cleaning up unneeded internal dependencies, therefore standardize on a common packaging approach and a common set of third-party packages and jar files, by refactoring the code to use microservices, by modernizing services infrastructure, for example, add caching, monitoring, and analytics cloud services, by modernizing the user interface, for example, come up to date on framework versions. You may want to remove to Web 2.0 or 3.0 hybrid model and even consider native mobile applications. This flowchart walks you through considerations for running on applications supported on Linux OS, as well as .NET applications, to ensure they can run on Cloud Foundry and IBM Bluemix. The flowchart also suggests the best runtime environment between Cloud Foundry build packs, Docker containers, and OpenStack VMs. This flowchart in turn walks you through considerations for running a Java application on WebSphere Liberty Profile on Cloud Foundry or IBM Bluemix versus running them on Cloud Foundry that supports Docker container or OpenStack VMs versus running them on WebSphere Application Server middleware offering on IBM Bluemix. So I would encourage you to walk through this flowchart so you can determine the best container for running your Java application on the IBM Cloud as well as open source Cloud Foundry platform.